Phoenix just spent an entire night that never dropped below 97 degrees. Only about 3 hours below 100 the whole night, roughly from 4:30 in the morning until dawn. That tied the warmest night ever recorded in the city. And it landed on the same day the thermometer hit 117. But the record itself isn't really the story. The real story is what the strongest heat dome of this summer does to the country if it holds for weeks, which is exactly what the forecast says is coming. Stay with this, and you'll understand what has scientists genuinely alarmed right now. On Friday, July 24th, at 3:14 in the afternoon, the official thermometer at Phoenix Sky Harbor International Airport hit 117 degrees. That reading broke the daily record for the date, topping the 116 set back in 2023, and it didn't arrive alone. Desert readings above 115 were widespread across the lower Colorado River Valley that same afternoon. But the afternoon number isn't the one that matters most. The number that matters most came after dark. When the sun went down that Friday night, Phoenix didn't cool off. The low bottomed out at 97 degrees, tying the warmest overnight low ever recorded in the city, a mark first set in July of 2023. That means the fifth largest city in America spent only about 3 hours below 100 degrees across an entire night. Then the sun came up and started the whole thing over again. Hold on to that 97-degree night, because it's the key to everything that follows. A hot afternoon is uncomfortable. A hot night is dangerous. The human body cools itself down overnight. And when the night never delivers that relief, the heat load just keeps stacking day after day with no reset. To understand how close this is running to the edge, you need the ceiling. Phoenix's all-time record for any day in any month is 122 degrees, set back in June of 1990. A day still remembered locally because commercial jets were actually grounded at Sky Harbor since the performance charts pilots relied on didn't even extend that high. This weekend's forecast has topped out in the 118 to 119 range, brushing right up against that all-time mark without quite reaching it, at least so far. But the raw record is almost beside the point. What tells you how relentless this is comes from the people living inside it. Local reporting out of the valley this weekend describes homes holding steady in the high 80s indoors with the air conditioning running continuously and never fully catching up. Extreme heat warnings have remained active across the Phoenix metro and much of south-central Arizona straight through Monday evening, with forecasters warning that even as the very hottest peak begins to ease slightly, dangerously warm mornings will continue across the valley for days yet. The engine behind all of this is a heat dome, a massive ridge of high pressure that has parked itself over the southwest and central United States. And here's what makes this one different from an ordinary hot spell. In the days immediately before this record fell, the National Weather Service had well over 400 active heat-related alerts posted across the country simultaneously, a count that had been climbing sharply day over day, stretching from the Mojave Desert all the way into the Central Plains. Extreme heat warnings, heat advisories, and extreme heat watches have blanketed a footprint covering something close to half the country at once. And this is not just an Arizona story. Iowa alone has carried some of the heaviest alert loads of any state this stretch, with forecasters there warning of heat index values climbing past 110 across multiple blocks of counties, even as some of those same counties woke up to dense morning fog with visibility down to a quarter mile. Fog at dawn and a dangerous heat index by mid-afternoon in the same place on the same day is the signature of an atmosphere absolutely saturated with moisture. And that moisture is precisely what makes heat like this so much harder on the human body than a dry desert heat wave would be. Out toward Las Vegas, desert valleys have been running well into the 108 to 114 range, with overnight lows only falling into the 80s and 90s. Down in the Coachella Valley, highs have pushed toward 120, with nights bottoming out in the mid-80s to mid-90s. Everywhere under this dome, the same pattern repeats. The days are brutal, and the nights refuse to recover. That ceiling is what has forecasters watching so closely. Upper air height is a direct measurement of how warm and how tall the column of atmosphere actually is, and the values being modeled over the interior west this week rank among the highest ever measured for this region. In plain terms, the models have been forecasting this dome to reach about as strong as a heat dome over this part of the country can physically get. And it isn't finished. Extended forecast discussions from federal meteorologists have been blunt about it, warning that extreme heat will keep making headlines across a large expanse of the country well into the coming week, with the ridge expected to remain dominant into the first days of August. Even Denver has been drawn into the story, with the city's July heat record from 1910, more than a century old, sitting well within reach on some of the hottest afternoons this stretch has produced. So the honest question isn't how hot it gets this weekend. It's what happens if this dome holds for weeks. Because duration, not peak temperature, is what turns a heat wave into a mass casualty event. And to understand why forecasters keep reaching for that kind of language, you have to understand why domes like this one are so hard to break down once they're established. A heat dome is a self-reinforcing machine. Air sinking underneath the ridge compresses and warms as it descends, which suppresses cloud formation, which lets even more direct sunlight pour onto the ground below. Now add the drought sitting underneath it. When soil is already dry, and right now roughly 2/3 of the country sits at least abnormally dry, incoming sunlight has no moisture left to evaporate. So instead of that energy going into evaporating water, nearly all of it goes straight into heating the air. The hotter air strengthens the ridge overhead. The stronger ridge suppresses even more cloud cover, and the loop tightens on itself. This is the drought heat feedback loop, and it's the specific mechanism that makes a strong dome like this one resistant to breaking down on its own. This particular dome is sitting on top of a severe drought footprint covering a meaningful share of the country, meaning the fuel for its own persistence is already loaded in underneath it before it even peaks. There's one more ingredient stacked underneath all of this, and it raises the floor on everything else. The Pacific is currently trending toward a significant El Niño state this year, with ocean temperature indices running well above the cooler baseline seen in recent years. What that means in practice is that this dome isn't building on top of an ordinary summer. It's building on top of an already globally warmed El Niño-influenced baseline. Every record this heat wave threatens starts from a higher launching pad than it would have a generation ago. That's why the overnight number deserves more attention than the daytime highs usually get. The daytime numbers grab the headlines, but the nights are where the actual danger lives. Think about what your body does overnight during a heat wave. It's trying to shed the heat load it accumulated all day, working to bring your core temperature back down to a safe baseline before the next day starts. When the outside air never drops below the high 90s, that recovery simply doesn't happen, and you begin the next day already behind. Most healthy people can cope with that for 2 nights. Push it to 2 weeks, and the vulnerable start to fall. Every system that keeps a person alive inside a heat wave, the human body, the air conditioner, the power grid, is a system with a limit, and every one of them is designed to get some kind of break at night. When the nights stop cooling, those breaks disappear and failures start to stack on top of each other. To see exactly where that leads, you only have to look at what happened the last time the same atmosphere ran the same experiment. The template is Phoenix 3 summers ago. In July of 2023, Phoenix ran 31 consecutive days at or above 110 degrees. The old streak record had been 18 days, set back in 1974. That summer didn't just break the record, it very nearly doubled it. The average temperature for that entire month, day and night combined, was 102, 7 degrees, the hottest month ever recorded in any city in the United States. And here's the part that matters most for right now. That summer, roughly 645 people died of heat in Maricopa County alone, more than half of every heat death reported to the CDC across the entire country that year from one single county. Nearly 2/3 of those deaths happened in July, the exact stretch of the calendar the country is walking into again right now. But the most important detail is the timing of those deaths, because it tells you how a disaster like this actually unfolds. The deaths didn't spike on the single hottest afternoon. They lagged the temperature curve by weeks. Heat mortality is cumulative. It builds slowly, night after night, as bodies that never fully recover keep falling a little further behind. And it falls hardest on the elderly, the isolated, people who work outdoors, and people with nowhere cool to go. That's what duration does. It's not one lethal afternoon. It's a slow grind that keeps collecting victims for weeks after the headlines have moved on to something else. Phoenix isn't the only entry in this particular ledger either. Chicago, in July of 1995, saw a heat wave kill roughly 739 people in the span of about a week. And it's remembered as a textbook case precisely because the killer combination was the same one building right now. Warm nights that never let up, high humidity and social isolation, elderly residents alone in upper-floor apartments with no air conditioning and windows they were afraid to open. Then there's the opposite kind of warning entirely. The Pacific Northwest, in the summer of 2021, when a heat dome parked over a region where extreme heat is genuinely rare and infrastructure was never built to handle it. The town of Lytton, British Columbia, hit 121. 3 degrees, an almost unimaginable reading for that latitude, and then burned to the ground the very next day. Hundreds of people died across that region in total. The lesson from all three, Chicago, the Pacific Northwest, and Phoenix, is the same. Every one of them was a duration event, and every one of them killed most heavily not at the peak, but in the days and weeks the heat simply refused to break. And as frightening as those historical numbers are, they're still not the worst-case scenario. They're the baseline. The worst case is the one scientists have actually modeled and put a number to. This is the scenario that keeps heat researchers up at night. It's the reason you keep hearing the word alarmed used around this event. It isn't the heat by itself. Phoenix, after all, survived 2023 with the power grid intact. The nightmare scenario is the heat plus a blackout at the same time. A research team led by Brian Stone Jr. at Georgia Tech modeled exactly that scenario and published the results in the journal Environmental Science and Technology. Their question was simple. What happens if Phoenix loses power during a multi-day heat wave? The answer was staggering. Their model projected that a blackout during a major heat wave could kill roughly 12,800 people in Phoenix and send about 790,000 residents to the emergency room for heat-related illness, close to half the population of the entire city needing emergency care within days. Set that against reality, and the math simply doesn't work. The Phoenix hospital system has only around 3,000 emergency department beds total. Stone himself described a blackout during a heat wave, in his own words, as probably the greatest climate-related hazard we can imagine. The reason is straightforward. Phoenix is a city that survives its summers entirely on air conditioning. Cut the power to a modern sealed home during a heat wave like this one, and the indoor temperature climbs past the point of survival within hours, not days. The detail from this week: homes already holding in the high 80s indoors, with the air conditioning running nonstop just to keep pace, is the leading edge of exactly that scenario. The margin between uncomfortable and unsurvivable in Phoenix runs directly through the power grid. The Stone study didn't just diagnose the problem either. It found that shading half the city's streets with trees would cut those projected deaths by roughly 27%, and that installing reflective cool roofs on every building citywide would cut them by around 66%. The fixes exist. What's missing is time, which brings this from a hypothetical straight into a live warning, because this summer the exact conditions that study modeled are lining up on the board in real time, and not just in Arizona, in Texas. On Tuesday, July 21st, the grid operator running roughly 90% of the Texas power system logged a demand of about 87,400 megawatts, a new all-time record, breaking the previous peak of 85,508 megawatts set during a heat wave back in August of 2023. Then, less than 24 hours later, on Wednesday, July the 22nd, that record fell again, with demand climbing to roughly 91,300 megawatts. Two all-time records broken on consecutive days. Grid operators are now projecting a summer peak that could climb well beyond 90 gigawatts overall, enough electricity to power somewhere in the range of 18 million homes. Part of that surge is simply the heat driving air conditioners across the state to run flat out around the clock. But part of it is genuinely new. Power-hungry data centers and cryptocurrency mining operations have been piling additional load onto the grid on top of the weather, right at the exact moment this dome is pushing demand toward its physical limit. To be fair to the operators, the grid has so far held through both record days without issuing conservation appeals or declaring an emergency, with tens of gigawatts of buffer capacity still available and battery storage playing a genuinely significant role in absorbing the evening demand spike as solar generation tapers off after sunset. But that resilience so far doesn't erase the underlying dynamic the researchers were warning about. A grid doesn't need to be struck by anything exotic to fail during a heat wave. It just has to be pushed to its ceiling and held there day after day until one hot transformer or one failed line at the wrong moment cascades into something larger. Extreme heat attacks a grid from both ends simultaneously. On the demand side, tens of millions of air conditioners run flat out and never cycle off because the night's never cool enough to let them. On the supply side, the heat itself degrades the equipment. Transformers and transmission lines carry less power safely when the surrounding air is scorching, and the large transformers anchoring the whole system run hotter and age faster the longer the heat holds on. So the exact moment demand hits an all-time peak is the same moment the hardware delivering that power is under its own greatest stress. That's the trap. It isn't one dramatic failure. It's a slow tightening of the margin between what the grid can deliver and what the state is demanding until a single component gives out at the worst possible hour, and the failure spreads outward from there. Back-to-back record demand days in the middle of a strengthening national heat dome is precisely the precondition the Phoenix blackout study was built to warn about. The heat isn't only stressing the systems people plug into either. It's discharging its own stored energy in a far more violent way along its edges. Here's something a lot of people miss about a heat dome. All that heat piled up in the interior is, in a very real physical sense, stored energy, and along the northern rim of the dome that energy tends to discharge violently. That's where the scorching dome air collides with cooler air and faster winds riding the jet stream to the north. The dome effectively acts like a wall, and storms ride around the top of it, fed by all the heat and instability packed in underneath. Forecasters sometimes call this pattern a ring of fire, and it turns the boundary of a heat wave into a corridor of severe weather. In the days surrounding this heat event, the northern plains have already seen dozens of preliminary severe weather reports in a single day, including tornado activity, dozens of damaging wind reports, and large hail reports well up from the day before, with some hail cores. producing stones for a genuinely unusual 8 minutes straight in parts of North Dakota, smashing windows in their path. That kind of duration is a signature of a slow-moving, continuously regenerating storm. It's exactly the behavior a deeply overheated, deeply unstable atmosphere tends to feed. This isn't a separate story from the heat itself. It's the same underlying energy coming out the side of the same machine. And underneath all of it, the dome is quietly grinding on the ground in ways that will show up in the weeks and months ahead, well after this particular round of headlines fades. Start with the food supply. This heat is intensifying at close to the worst possible moment for American agriculture, right as corn and soybeans across the plains and the Corn Belt hit their critical reproductive stage, the window that effectively decides the final yield for the entire growing year. Hot, dry conditions have been steadily draining soil moisture across the central and southern plains, with extreme to exceptional drought now covering a substantial share of states like Nebraska. Pastures are deteriorating, ranchers are already facing rising feed costs, and that kind of pressure eventually ripples out to grocery prices for everyone, regardless of where they live. Then there's the fire line. Satellite monitoring has been detecting thousands of wildfire hotspots across the country in single 24-hour windows this stretch, with several large fires already burning at only single-digit to low double-digit % containment, some running well over 100,000 acres. Red flag warnings have stretched across the interior west, with afternoon humidity in some areas dropping into the low teens. This is the same feedback loop that helps the dome sustain itself, just running in the other direction. Drought dries out the vegetation. Heat bakes it further. Parched ground can no longer cool itself through evaporation, which feeds heat right back into the dome sitting overhead. Every additional day this dome holds cures the vegetation a little drier and pushes fire danger a little higher. And in a fuel bed that dry, all it takes is a single outbreak of dry lightning, thunderstorms that deliver plenty of electrical activity but almost no rain, for a fire season to genuinely detonate. There's one more twist worth understanding, a real no-win built directly into the pattern. The ring of moisture around the dome's edge is this region's only natural exit ramp from the heat, but that exit has its own trapdoor. If that moisture surges inward, it does cut afternoon temperatures, but it also risks dumping heavy rain onto fresh burn scars in steep terrain, ground that can no longer absorb water properly, turning a heat emergency into a flash flood emergency within hours. So the dome effectively offers two paths forward, and both of them lead somewhere genuinely dangerous. It either holds and the heat keeps grinding on, or it breaks in a way that trades the heat for flooding. That's the box the Southwest is sitting in right now. The very moisture that could offer relief is also the thing most likely to turn deadly the instant it arrives, over ground that fire has already baked hard and stripped of vegetation. There's no clean exit from this pattern, only a choice between two different kinds of emergency. It's worth addressing two claims that tend to circulate any time a dome like this parks over the country, because the honest answer is more interesting than either myth. The first claim is that events like this are engineered, that someone is deliberately manufacturing this heat through weather control technology. The problem is simply the energy budget involved. Reorganizing the thermal structure of the atmosphere across millions of square miles requires an amount of energy that dwarfs anything any facility on Earth could plausibly produce, by many orders of magnitude. And this exact dome was forecast days in advance by ordinary physics-based computer models running on public data. An engineered artificial anomaly wouldn't confirm those forecasts on schedule the way this one did. It would break them. The second claim making the rounds is that the records themselves are somehow inflated, fabricated by hot airport thermometers sitting on sun-baked tarmac. This one actually contains a real kernel worth respecting. Airport sensors genuinely can run a few degrees warmer than a nearby shaded neighborhood because they sit on large, flat, dark surfaces. But a temperature record isn't a comparison between an airport reading and someone's backyard. It's a comparison of that one specific station against its own decades of history, the same instrument at the same site across time. And the single fact that dismantles this theory entirely is that 97-degree overnight low. A reading that warm at 4 in the morning cannot possibly be a sun-baked tarmac artifact, for the simple reason that at 4 in the morning, there is no sun to bake anything. The record this theory can't touch is exactly the one that matters most. So where does this actually go from here? There are a handful of specific, checkable signposts worth watching. First, whether the upper air ridge over the interior west continues building toward the extreme values models have been forecasting, which would confirm this really is one of the strongest heat domes ever measured over that region. Second, Phoenix's overnight lows specifically. Watch the nights, not just the afternoons. A continued run of lows sitting near 90 degrees is the exact signature that preceded the worst of the 2023 death toll. And it remains the real measure of how much danger is quietly accumulating night after night. Third, the national alert count, which has already been climbing sharply and will track the dome's expansion or contraction in something close to real time. Fourth, Grid demand in both Arizona and Texas as this week plays out. Texas has already broken its all-time demand record twice in consecutive days. Every additional record edges the system closer to the exact precondition the Phoenix blackout study was built to warn about. And finally, the calendar itself. Current forecasts hold this general pattern into the first days of August, the same window that produced Phoenix's 31-day streak 3 summers ago. The straight red is this. The strongest heat dome of the summer is still holding strong, having already delivered a record day and a record-tying night to a major American city, with the national forecast keeping it largely locked in place for what could be weeks longer. Duration, not peak temperature, is the variable that turns a heat wave into a genuine disaster, and every indicator right now points toward duration. The good news is that domes like this do eventually break. A trough could dig in over the eastern half of the country and shove this one westward. The monsoon could surge earlier than expected. Early August could open with the pattern finally relaxing on its own. That's a real possibility, and it's worth holding on to. But the forecast as it stands today points toward persistence. And the real question this heat is forcing isn't how hot it gets this particular weekend. It's which gives out first in the weeks ahead. The pattern itself, the records currently falling almost daily, or the systems, human bodies, air conditioners, and power grids alike, that 30 million or more Americans are depending on to get them through it. And whether the answer to that question arrives before or after the first genuinely major failure,